So a class predicts that a local population of animals will double in size every 12 years. It started at 50, and how can we get to n years? Well, we are going to double for the number of years divided by 12. Every time this reaches 12, we multiply it by 2 again. This is an exponential growth. It's not constant. It's being multiplied by a value. If we look at the change in this table, as the years go up by 1, we do not see a constant increase for salary. It's going up a little bit more each time, so that's suggesting that it's increasing by some sort of percent. If you wanted to find out which percent was correct, you could take one of these rates, like 1140, and divide that by 38,000. And that's where you find that 3 is correct. We are increasing by a specific amount each year. So that is a slope. We are increasing in a linear fashion. We are looking for a model that decreases exponentially over time. So if it's a flat amount each year, that's a constant rate. Those are both linear. And which one is decreasing? 8% more or 8% less? So we're investing $1,000. And V is the future value, and R represents the annual interest rates. Then we compare compounding that interest daily versus compounding that interest annually. So which one goes up faster here? That's when we compound daily compared to annually. So as R increases, V increases more rapidly if we compound not annually rather than daily, but daily rather than annually, which is choice B. We don't see V increasing at a constant rate because it has a curve. And if you follow 15% to annual, that's actually going to be a little bit below because that's the square, not the circle. We want to see a negative association that is not linear. So this one is linear, that's a constant rate. This does not have any sort of association. This is a parabola, which is not going to show a negative association. This one here, because of the curve, is our answer. It's going down, but not at a constant rate. As we plus 5 on the left, we plus 900 on the right. As we plus 5 again here, we plus 9,000. Are we increasing at a linear rate? Nope. Are we going up? Yes, exponential growth. As x goes up 1, y increases by 14/4. As x goes up another 1, y increases again by 14/4, so there's a constant rate of change. We can rule out the ones that have exponential equations. And 14/4 we can reduce to 7/2 for our slope. Every 8-day interval, half of the mass of the isotope remains. It's not decreasing or increasing linearly because when we take 50% each new 8-day cycle, our decline is going to be different amounts. So it's going to decrease exponentially. So eating crunchy green cereal, we see that each serving gives you 5% of your daily allowance of potassium. So X is the servings, and for each one of them, we see 5%. So P is going to equal 5 times X. As the number of servings increases, we multiply by 5 to find out what percentage of the daily allowance of potassium we have ingested. Though it involves a percent, it is increasing at a linear rate.